The topic I have for you this afternoon is basic circuit connection. And under this topic, you will learn how to connect or construct a simple circuit. The objective of this topic is for you to learn how to use or connect DC power source in an electrical circuit. Also for you to learn how to properly connect two different meters, which are voltmeter and ammeter in the circuit. To start with, what is electrical circuit or electronic circuit? It's an interconnection of electronic components in such a way that there will be a complete conducting path for the flow of current. In any circuit, you are connecting either electronic circuit or electrical circuit. The essence of you having, the essence of you connecting up a circuit is to ensure the flow of circuit, the flow of current in your circuit. So in your circuit, you must make sure that it's complete, there is no disconnection. Voltmeter, how to connect voltmeter in an electrical circuit. That's the first one I want to teach you. Connection of a voltmeter across a load resistor in electronic circuit is the first one we want to teach you this afternoon. Voltage is usually measured in volts, and voltmeter is usually connected in parallel. Why? Because the voltmeter has a high internal resistance. There is a circuit giving you in page 13 of your manual. Quickly open to page 13 of your manual. We see a circuit diagram with 15-volt source.
There's a break in the recording.
With 15-volt source. This 15-volt, you can see the sign. This sign is a sign for DC source, DC power supply. You can see two cells forming the battery, showing that this is a DC power supply of 15 volts and is connected in series with this 100 kilo ohm resistor. This represents the voltmeter, which is connected across the two terminals of the 100 kilo ohm resistor. Now, I will take you to the equipment to know how to connect the voltmeter in parallel across the load resistor. The moment you get to the equipment, you must not first switch on the power supply until you are through with your connection, and you must know how to trace the circuit. The moment you get the circuit tracing, just as I trace it now, it is very simple. You bring it to the circuit. This is your power supply. This is the negative terminal. This is the positive terminal. These are the control knobs. This control knob you must ensure that is set fully counterclockwise. The essence of setting it fully counterclockwise is for you not to allow this power supply to generate any voltage value by the time you power it on. It will be by yourself that you will gradually set it to your desired value. That is the given value in your manual. And this is the current control knob. For the current limit, this one must be set fully clockwise. That's the setting. Now, let's quickly move to the connection. This is the positive terminal of the power supply, the negative terminal of the power supply, and this is the negative terminal of the voltmeter. This meter is 2-in-1. It is called dual meter. It comprises of voltmeter and ammeter. This, where you see DC volts, it represents voltmeter, and where you see DC current, it represents ammeter for current reading, and this side is for voltage reading. We use our voltmeter for measurement of voltage, and the units of voltage is volts. I've connected both negative terminals together. The two negative terminals now will be connected to one of the two terminals of the 100 kilo ohms resistor. You must ensure tight connection. I'm left with two terminals. The positive terminal of the power supply is connected with the positive terminal of the voltmeter. The two connected together, we go straight to the second terminal of the resistor. Can you see that this one has removed? That was why I said you must ensure tight connection. Now, the next thing, the circuit is complete. The next thing I have to do is to switch on the power supply. The power supply is on now. There will be given 15 volts as our source voltage. The next thing is to gradually set this to the given value, which is 15. This 14.3, you use the second control knob, which is fine, to fine tune to get your 15 volts perfectly. Now, the next thing is to take the corresponding voltage drop across this 100 kilo ohms resistor. Let's see. No, I set this on 30 volts. This is an analog voltmeter and it is calibrated. The upper scale ranges from 0 to 10. The lower scale, it ranges from 0 to 30 volts. But it's very easier for me to take the upper scale. I'll just convert this 10 to 30. It means each division here now is multiplied by 3 in order to get 30. And if you like, you can use the lower scale. But it's because I can see the upper scale clearly. Now, this is 15. This is 15 volts. This is 15 volts. Also, you can decide to use the lower scale. You can see that the lower scale is the maximum number there is 30. If you are using the lower scale, it's still the same thing. You can see this is still 15 volts. 15 volts, around 15 volts of 14.9. It's not perfectly 15 volts. You can just take it as 14.9 volts. That's the voltage drop across the 100 kilo ohm resistor. Now, there are 3 connections that you are going to connect in this topic. The first one, we've completed the first one. The next one now that I'm going to show you how to connect is an ammeter. How you can connect an ammeter in an electronic circuit. The second connection is connection of ammeter in the circuit. How you can connect your ammeter in the circuit. An ammeter is a measuring instrument that we use to measure current, and the unit of current is ampere. That is, current is measured in ampere, and your current is the movement of electrical charges in a definite direction. Now, I told you the other time that this meter is 2-in-1. That is, it serves 2 purposes. We can use it as voltmeter and as well as ammeter. This side previously was used as our voltmeter. Now we are using the second side as our ammeter. But before this one can work as an ammeter, you have to do a little setting. This control knob must be set to DCA. You can see DCA written here for this one to work as your ammeter. This is the control knob for your ammeter. You can see this white mark here. That is what will be pointing to the given range in your manual. And in the circuit, the range given you for your ammeter is 0 to 1 milliamp. You set it to 1 milliamp. These are the two terminals to your ammeter. Now the connection. Look at the circuit diagram, page 14 of your manual. I want to teach you how you retrace the circuit in order to get your connection perfectly. The circuit is polarized. You can see these terminals. The symbols, the positive and the negative. They are very important in your connection. You have to follow the polarity. The negative terminal of your power supply is connected to the positive terminal of your ammeter. And the negative terminal of the ammeter is connected to first terminal of your 100 kilo ohm resistor. The second terminal of the resistor is connected directly to the negative terminal of the power source. Now this is the connection. This is the positive terminal of the ammeter, and this is the positive terminal of the power supply. The two are connected together. We are left with negative terminal of the ammeter. The negative terminal of the ammeter will go straight to either of the terminal of the 100 kilo ohms resistor. You can see the way I'm inserting it into the terminal. We are left with the negative terminal of the power supply and one terminal of the resistor. You connect it. Now the circuit is complete. The next thing now is to switch on the power supply. That is, you power it. You can see that the voltage reading starts from 0. There is no voltage that this one can generate now that is high enough to damage anything. No reading. That's the essence of turning it fully counterclockwise. Now we want to generate the given 50 volts. This current control knob, for current you have to set it fully clockwise. Don't forget, while we were using it the other time to get a reading for voltmeter, this current control knob was set in the reverse direction, that is fully counterclockwise. Now because we want to take current reading, we are setting this one to fully clockwise. Now this, you have to set it to the given voltage value, which is 15 volts. And this current control knob, that is current limit, it must always be fully clockwise. Either you are using it for voltage reading or you want to get a current reading, it is current limit. It must always be fully clockwise for you to have reading on your voltmeter or your ammeter. Now the range given us in the manual is 1 milliamp. You can see that I've set the current control knob to 1 milliamp, and this one is set on 1 milliamp. The calibration has to change. You have to convert this. You can choose either the upper scale or the lower scale, but the upper scale is easier to convert than the lower scale. You can see the upper scale, it ranges from 0 to 10. Because this has been set to 1 milliamp, this upper scale is not up to 10 again. Everything will be converted to 1 milliamp. And for you to do that, instead of having 1 here, it will be 0.1, 0.2, 0.3, 0.4 to 1. The reading of this one now, you can see from here to here is 0.1. We have 0.15. That's the reading of the current from the ammeter. And it's not just 0.15. It means 0.15 milliamp. There must be units for your reading. If you are just taking reading, you are giving us digits number, it has no meaning. You must not forget the unit of your current. That's the reading for our current given us by the ammeter. The connection still remains 1. The next connection now, which I will show you how to carry about, is the connection of the 2 meters. That is the voltmeter and ammeter. How you can connect, we've connected differently now. We first connected voltmeter alone in the circuit. Presently now, we've connected ammeter in a circuit. The next connection now, which is going to be the last one, will now be the combination of the 2 in a circuit. I'm moving to the third connection. The third connection, as I told you earlier, is the connection of both the ammeter and voltmeter in a circuit. Previously, we connected an ammeter in series in the circuit. You don't need to disconnect the previous connection, which is the connection of an ammeter, because we just connect the voltmeter in parallel. We want to use this one. We want to use this. This is a digital multimeter. You've been told under component identification, it was shown to you. The digital multimeter, you can use it to read different parameters, your current, your voltage, but I'm using it to read. I'm using it for my voltage reading. That's why I set it on timing on DC. This is, you can see the symbol for DC voltmeter, and this is the common terminal. You can see the pros. This is the common terminal, and the unit for voltage is here. Voltage is measured in volts. That's how to know where to connect it. You can see the ports. On top of this port, you see V written in red. That is positive, and this one is the positive probe, the one that is connecting to this port where you have a fault sign, and this is common ground, that is negative. You can see the probe. Now I just want to connect across the two terminals of the 100 kilo ohm resistor. The first thing, you disconnect this one. Following the circuit diagram given you on page 15, the positive of voltmeter, of ammeter and power supply had already been connected together. The next one is to connect the negative of the ammeter together with the positive of the voltmeter. That is what I'm connecting together now. If you check your circuit diagram on page 15, you will see that voltmeter, the positive terminal of the voltmeter and negative terminal of ammeter are connected together, and the two enter one of the two terminals of 100 kilo ohm resistor. We are left with the negative terminal of the power supply and the negative terminal of the voltmeter. You connect the two terminals together as well, and the two terminals will be connected straight to the remaining second terminal of 100 kilo ohm resistor. That is what I'm doing now. Always ensure tight connection. Now the circuit is complete. The next thing now is to switch on the power supply. As usual, as we've been doing before, you come to the voltage control knob for voltage reading. you set it to the given value, which is 15 volts. It's more than 15, so it's perfect now. This is 15 volt exactly, and the current reading I've told you initially why we were taking current reading from ammeter concerning the calibration. You must not forget that the ammeter is still on 1 milliamp. Don't make a mistake of counting this one to be 1 point number in milliamp. No, everything here is 1. I'm using the upper scale. This is 1.5. 1.5 watts. It's not 1.5 volt, but 1.5, but it's 0.15 milliamps. Everything here is 1. This one is 0.1, 0.2 like that. Now we have less than 1. This is 0.15 milliamps. That's the current reading. Now let's see the reading of our voltage from the digital multimeter. It is 15 volts. See, 15.1. 15.01, approximately 15 volts, which is the source, which is equivalent of the source voltage. That's the voltage drop across 100 kilo ohms resistor. That takes us to the end of the basic circuit connection. There are some questions in your manual which will be communicated to you later, or now you will go about it. Thank you.